All right, so number one, we're factoring. So factoring, remember, is the distributive property backwards. So this is a quadratic expression. There's an x squared. That's what makes it quadratic. So our standard form is ax squared plus bx plus c. And this whole section we're factoring when the number next to x squared is 1. So a equals 1. And it's an easier way to factor. Next time we'll do a equals different numbers. So b is the number next to x. So b is 14 and c is the constant. It's by itself. So when we factor, we find c and we find all the numbers that multiply to 45. So 1 times 45. And again, if you're not good with your times tables, just start dividing until you do not get a decimal. So 3 and 15, not 4, it's a decimal. 5 and 9. So now if I wasn't sure, that's it. I would go until 9. Because once we've hit 9, we're back to where we started. We already have that one. So here are factors of 45. We want to find which one of these add or subtract to b. Can you see it? 5 plus 9 is 14. So that's the one. That's one we want to use. So when we write in factored form looks like this. And these are actually plus or minus. So R stands for root. Oops. And these are roots. 5's a root and 9's a root. So we're going to put those there. X 5, X 9. And then the last step is to determine if you're going to use plus or minus. On this one, everything's plus. But what happens is these need to 5 times 9 is 45. C. 5 plus 9 is 14, which is B. So multiply to C, add to B. And then I'm going to hurry and check and make sure we did it right by multiplying, by using the distributive property. So x plus 5, x plus 9. If we use the distributive property here, x times x is x squared, 9x, 5x, 45, the middle two add. That's going to give us what we started with if we did it correctly. And we did. So x plus 5, x plus 9 is our factored form.